Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on UPSC previous year's question paper. So in this video I will discuss 2023 paper 2 question one by one. So let's start the video. So first question is here. Section A. Calculate the 0 point energy of a particle is an infinite potential wall for the following cases. 1. A 100-gram ball confined on a 15-meter long lines. And 2. An oxygen atoms confined to a 2 into 10 to the power 10 meter lattice. And question number 3. An electron confined at a 10 to the power 10 meter atoms. But 0 point energy is not important for a macroscopic object. Comment. So comment out this. And question number 1b. Consider a particles of the mass m and charge q moving under the influence of a one-dimensional harmonic oscillator potentials. Assume it is placed in a constant electric field E. The Hamiltonian of the particle is therefore is given by s equal to p square by 2m plus 1 by 2m omega square by x square minus q e x. Obtain the energy of the expression and the wave function of nth excited state of the particles. In question number C, a particle of the mass m is an aspherically symmetric attractive potential of radius a. Find the minimum depth of the potential needed to have bounded state of zero angular momentums. And question number D is here. A beam of hydrogen atom emitted from an oven at 400 Kelvin is sent through a Stern-Gerlach experiment having magnet of length 1 meter and the gradient field of 10 Tesla meter. Calculate the transverse deflection of an atom at the point where the beams leaves the magnets. And question number 1e. If an atom is placed in a magnetic field of the strength 0.1 Weber meter square, then calculate the rate of precessions and torque on a electric with L is equal to 3 in the atoms. Give the magnetic moment of the electron makes an angle of 13 with the magnetic field. And question number 2a. An operator P describes the interaction of two spin 1 by 2 particles. P is equal to 1 plus B sigma 1 into sigma 2, where A and B are constant and sigma 1 and sigma 2 are Pauli matrix of the two spin. The total spins of the angular momentum S equal to S1 plus S2 is equal to 1 by 2 H sigma 1 plus sigma 2, so that P, S square and SZ can be measured simultaneously. In question number 2b, consider a stream of a particle of mass m each moving in a positive x direction with kinetic energy E toward the potential barrier. Px is equal to 0 for x is less than 0 and Px is equal to 3 E by 4 for x is greater than 0. Find the fraction of the particle reflected at 0, x is equal to 0. So this question must see. Consider the potential Vx is equal to 0, 0 is less than x, x is less than a. Infinitive elsewhere. Question 8. Estimate the energy of the ground state as well as those of the first and second excited state for a electron enclosed in a box of size a is equal to 10 to the power 10 meters. And 2 is 1 gram metallic sphere with the moving in a box of size A is equal to 10 centimeter. Question will be discuss the importance of the quantum effect for both of these systems. Question number C. Estimate the velocity of the electron and the metallic sphere using uncertainty principles. And question number 3a. What is vector atom model? How the principal feature of the vector atom model were explained by Stern-Gerlach experiments. And question number 3b. What is Landy's G factor? Evaluate the Landy G factors of P13 levels in the 2p3s configuration of carbon 6 atoms. Also calculate the splittings of the levels when the atom is placed in a external magnetic field of 0.1 Tesla. And question number 3c. What is Raman effect? Explain the quantum theory of Raman effect and rotational structure of a Raman spectrum. In question number 4a, a particle constrained to move along x-axis in the domains 0 is less than x is less than L has a wave function sin x sin is equal to n pi x by L, where n is an integer. Normalize the wave functions and evaluate the expectations value of the momentum of the particles. And question 4b, evaluate the most probable distance of the electron of the hydrogen atom in its 2p state. What is the radial probability density at the distance? Question number 4c, what is nuclear magnetic resonance? NMR. Nuclear magnetic resonance. Explain its workings, principle, and use magnetic resonance imaging systems. And question number section B. Question 5. What could you establish that VE and VE are two different particles? And question number 5b. What is the age of the fossils that contain 6 gram of the carbon 14 has a decay rate of 27 decay per minute? Given that you did this. In question number 5c, name the interaction by which the above nuclear decay occur. So here this above equation: first, second, third, fourth, fifth, sixth, 7, 8, and 9, 10. So total 10 marks. In question number 5d, derive the diffraction condition using reciprocal lattice. This is solid state physics. What are these conditions known as? Question 5e. So the Fermi level shift upward closer to the conduction band in a n-type semiconductor and shift downward closer the valence bond in a p-type semiconductor. So this is related of solid state. So Puri and Babbar books questions. And question 6a, establish the Rutherford scattering cross sectional formula for a particles be considering the standard Egyptian and the symbols by using nuclears in a cubical box of a length equals to the nuclear diameter 10 centimeter. Calculate the kinetic energy of the highest level occupied nucleon of iron 56 nucleons. Question number 6c, what do you understand by nuclear force? Explain the meson theory of exchange forces. And 7a, explain the classical theory of diamagnetism so that the susceptibility of diamagnetic substance is directly proportional to the atomic number. What all the electron in an atoms contribute to diamagnetism. And 7b, derive an expression for the specific heats of the solid based on the divide theory. So how is agree with the experimental value? What is the most important assumption of divide theory of the comparison of Einstein theory? In there any drawbacks of the divide theory? So divide theory is TQ. So what is different about Einstein theory and divide theory? And question number 7c, what is a neat circuit diagram? Explain the working of Wien-Bridge oscillators. And question number 8a, what do you understand by a critical size of reactors? Explain the main feature of a nuclear reactor. Question number 8b, what is superconductivity? Explain the Meissner effect. What is superconductor should be a diamagnetic particles. And question number 8c, Determine the input and output impedance of amplifier in given figures. So OPMP dash sit gives Z in is equal to m ohm, Z out is equal to 15. So A naught is equal to 1 times 1000 10,000 lakh 10 lakh. So find this close value voltage low voltage gains. So that is the question here. This, so here 2 lakh, right? So this is OPMP. So there are two types of OPMP: inviting, non-inviting. We know that. So that is all related to this discussion. It for today. Thank you very much and good of luck.